Hello everyone and welcome back to my How To Education channel. As I promised you on Sunday, here is the first lecture of the 2023-2024 academic year. How to Ace Economics Working with Elasticity Part 3. After watching this video, don't forget to leave me your feedback. Before the summer vacation, we covered some types of elasticities other than that of price. Today, and in some of the upcoming sessions, we are going to focus solely on the price elasticity. In addition, we will be speaking about revenue. To conclude this lecture, we will analyze the way in which price elasticities impact revenue. I found the table of the upcoming slides in the Principles of Microeconomics book 2E, page 116. It portrays the results of a large number of studies done in order to find the price elasticities of a variety of products. Once analyzing this table, remember that when the elasticity is less than 1, we call it an inelastic demand or inelastic supply. When the elasticity is exactly equal to 1, we call it an unitary demand or a unitary supply. When the elasticity is greater than 1, we call it elastic demand or elastic supply. The table is in increasing order of elasticity, as in from the smallest to the largest. The lowest price elasticity is that of 0.12, which corresponds to housing and to economy class air travel. Both of these goods are followed by rail transit at rush hour that has a price elasticity of 0.15. Moving on, we have electricity 0.2, taxi cabs 0.22, and gasoline 0.35. This second part of the table is still showing goods and services with price elasticities lower than 1. We have first class air travel 0.4, wine 0.55, beef 0.59, business class air travel 0.62, kitchen and house appliances 0.63, and basic cable TV 0.69. We continue the third part of the table with 3 different groups of goods and services. The first group of elasticity below 1, the second group of elasticity equal to 1, and the third group of elasticity above 1. So we have chicken 0.64, soft drinks 0.7, beer 0.8, new car 0.87, rail transit at off-peak 1, and computer 1.44. Lastly, we have the above 1 elasticities. Medium cable TV 1.51, premium cable TV 1.77, restaurant meals 2.27. Note that from housing all the way to a new car, price elasticities are less than 1, which implies an inelastic demand. The off-peak rail transit is the only service from the table that has a unitary elasticity. Computer, medium and premium TVs, and restaurant meals have price elasticities above 1, which implies elastic demand. But what does this all mean? Remember that for an inelastic demand, when the price increases, quantity demanded decreases, but by a lower amount than the change in price. And when the price decreases, quantity demanded increases, but again by a lower amount than the change in price. For an elastic demand, when the price increases, quantity demanded decreases by a higher amount than the change in price. And when the price decreases, quantity demanded increases again, but by a higher amount than the change in price. For a unitary demand, when the price increases, quantity demanded decreases by the exact same amount as the change in price. And when the price decreases, quantity demanded increases again by the exact same amount as the change in price. Therefore, it is now easy to understand why housing, economic class air travel, rail transit at rush hour, electricity, taxi cabs, and gasoline have the lowest elasticities. Housing, transportation at rush hour, gasoline, and electricity are basic everyday needs, meaning that even when the price increases, the quantity demanded will not decrease as much, or else people will not be able to move on with their daily tasks. In addition, economy class air travel is the cheapest one. That means people that actually need to travel by plane will not have any other choice even if the price increases. It is also easy to understand why computer, medium cable TV, premium cable TV, and restaurant meals have elasticities above 1, as in elastic demand. If the price of a certain type of computers and medium or premium cable TV increases, people will switch to either cheaper brands or versions of the same product or to a new product altogether. Thus, the quantity demanded will decrease by a larger amount than the increase in price. In addition, if the price of restaurant meals increase, again the decrease in quantity of meals taken at restaurants will be even larger than the increase in price, as everyone will start taking their meals at home. In the case of the off-peak rail transit, which is the only unitary elastic demanded service, we say that since we're tackling a transportation service not on rush hours, the people using the service at that time do not seem to be in a hurry. Therefore, if price increases, people can simply not choose this service, meaning that if prices increase, quantity demanded will decrease by the same amount. Some might be asking why we directly moved from the concept of elasticity to that of revenues. Well, before answering this, it is important to define the term revenue. Revenue is the money that comes from all business operations. In order to calculate it, one has to multiply the number of units sold or services given by the price of each good or service. In other words, revenue equals price times quantity. Let's say that you sold 30 pens, each costing $1. This means that your revenue is $30, as in $1 per unit times 30 units. Now, let's try to relate the concept of elasticity to that of revenue. As a recap, we first said that there are three types of elasticity: inelastic, unit elastic, and elastic. Once we moved on to revenue, we said that it's equal to price times quantity. The easiest way to examine this relationship is to measure the change in revenue according to a change in price for all of the three situations: inelastic, unit elastic, and elastic. No matter the type of elasticity, the initial revenue is always price times quantity. In the case of elastic demand, when price increases, quantity demanded decreases by a larger amount than the change in price. When price decreases, quantity demanded increases by a larger amount than the change in price. Therefore, if price increases, the decrease in quantity demanded will be larger than the increase in price. Thus, total revenue decreases. If price decreases, the increase in quantity demanded will be larger than the decrease in price. Thus, total revenue increases. In the case of unitary elastic demand, when price increases, quantity demanded decreases by the same amount than the change in price. When price decreases, quantity demanded increases by the same amount than the change in price. In this case, whether price increases or decreases, quantity demanded will change by the same amount but in the opposite direction. That is, if price is double, quantity demanded halves. If price is divided by 3, quantity demanded is multiplied by 3. Thus, revenue stays the same in all cases. In the case of inelastic demand, when prices increase, quantity demanded decreases by a smaller amount than the change in price. When prices decrease, quantity demanded increases by a smaller amount than the change in price. Therefore, if prices increase, the decrease in quantity demanded will be smaller than the increase in price. Thus, total revenue increases. If prices decrease, the increase in quantity demanded will be smaller than the decrease in price. Thus, total revenue decreases. This is it for now, but if you have reached the end of this video, it is because the content is helpful to you somehow. If this is the case, then don't forget to give your friends and acquaintances the opportunity to have access to it by liking, commenting, and sharing this video, and by subscribing and joining the channel. We will continue with How to Ace Economics, Working with Elasticity, Part 4, next Wednesday. But before that, I will see you all on Friday with How to Ace Finance, Present and Future Values of Multiple Cash Flows. Thank you so much.